everybody, my name is Aiden, and today I'll be reviewing Unit 4 of AP Physics, Energy and Work. So, the first thing about energy is that the unit is joules or Newton meters. Most people just use the J because it's easier. And then there are three main types of energy, and they're divided into two different buckets. There's kinetic energy, and then there's potential energy or stored energy. And there's different types of potential energy. In fact, we'll get to that. So kinetic energy is just like motion. It only exists when an object has speed or velocity of some sort, and you calculate it with half times mass times velocity squared. Potential gravitational energy exists when an object is above Earth, or actually any planet or anything, but those are, the equation for that for other planets or asteroids or whatever isn't quite as simple. But in this case, potential gravitational energy, it's just mass times acceleration due to gravity times the height or the vertical displacement from Earth's surface. And then potential spring energy exists when there's something elastic. 95% of the time it'll be a spring. Sometimes it'll be something like a rubber band or something, but it's calculated with half times the spring constant times displacement squared. And so the biggest concept for this unit, the thing you'll be using in almost all of the energy problems, is conservation of energy. And it basically just goes like this. If no external forces are applied to the system, the mechanical energy in the system will stay constant. And there's only one exception to this, and it isn't an internal collision, it is an inelastic internal collision. An elastic internal collision can occur, and in that case, energy will be conserved, in which two objects in the system, they're both part of the system, collide, and then energy is conserved. And usually the AP test will convey that it's an inelastic collision by saying that the two objects stick together after the collision, which means you cannot use conservation of energy for the problem. Other times they'll make you manually do the calculation to figure out energy wasn't conserved, but most of the time they'll tell you that the objects stuck together, and in that case you'll have to use conservation of momentum, which is in the next unit. So work is just change in energy, and you can calculate it with force times distance, but the force has to be parallel to the displacement, so in one direction or the other, it's kind of a linear thing like that. And on the equation sheet, it's just change in energy equals work equals force times distance with the two little parallel lines here, or force times distance times cosine, something like that. And so we'll get to the first energy problem. So an object with mass m is suspended at rest from a spring with a spring constant of 200 newtons per meter. The length of the spring is 5 centimeters longer than its unstretched length L. A person then exerts a force on the object and stretches the spring an additional 5 centimeters. What is the total energy stored in the spring at the new stretched length? So potential spring energy equals half times k times x squared. So half is just 0.5 times 200 newtons per meter times the original displacement plus the added displacement, which is 0.1 meters total, because it says 5 centimeters plus 5 centimeters, 0.1 meters squared. So 0.5 times 200, 100, and then 0.1 squared is 0.01. So 100 times 0.01 is 1 joule, and that is the total energy stored in the spring at the new stretched length. The second example problem is find the net work done on a box if it is pulled 5 meters across the floor using a cord with a tension of 60 newtons at an angle of 30 degrees from horizontal, while friction applies a constant force of 5 newtons. So in this case, it's actually net work. So this is a pretty complicated problem because it's net work because there's two different opposing forces, and you have to do an angle because one of the forces is not parallel to the displacement. So that's kind of what I was hinting at before with this problem. So you have to do cosine of the 30 degrees because you're trying to find, a triangle like this. You're trying to find the horizontal part. So that's the cosine. So cosine of 30 degrees times 60 newtons times 5 meters minus the friction force, 5 newtons times 5 meters. So this is cosine of 30 degrees times 60 times 5 minus 5 times 5. And that is 259.8 joules minus 25 joules equals the net work of 234.8 joules. Thank you.